press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we finish up to 10th problem, correct? So we go for the next problem, 11th problem. So it is a paragraph problem. I read the problem, observe carefully. A manufacturer has 3 machine operators A, B and C. A manufacturer has 3 machine operators A, B and C. The first operator A produces 1% defective item, and whereas other 2 operators B and C produces 5% and 7% defective items respectively. A is on job for 50% of the time, B is on job for 30% of the time, and C is on the job for 20% of the time. A defective item is produced. A defective item is produced. What is the probability that it was produced by A? What is the probability that it was produced by A? Okay, so one by one, machine A we treated as E1, machine B we treated as E2, and machine C we treated as E3. Okay, so we write the events. Let E1 event, E1 be the event, this is problem number 11th one, be the event for machine A. E1 be the event for machine A. Next, E2 be the event for machine B, and E3 be the event for machine C. Okay, time availability for machine A 50%. So probability of E1, so 50%, 50 divided by 100. Probability of E2, 30%, 30 divided by 100, and probability of E3, how much? 20%, 20 divided by 100. 20 divided by 100. What about the A event? A event, let A be the event. The chosen item is defective. The chosen item is what? Defective. The chosen item is defective. So for that, probability of A given E1 is, probability of A given E1 is 1%. So that is 1 divided by 100. Probability of A given E2, probability of A given E2 5%, 5 divided by 100. So probability of A given E3, probability of A given E3 7 divided by 100. 7 divided by 100. Probability of A given E3. Right below. Probability of A given E3. 7 divided by 100. 7 divided by 100. So what he has? What is the probability? It was produced by machine A. So to find probability of E1 given A. To find probability of what? E1 given A. So according to Bayes' theorem, according to Bayes' theorem. So everyone know that E1 given A is equal to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus right below probability of E3 into probability of A given E3. Probability of what? A given E3. So we substitute all the values. We substitute all the values. That implies P of E1 given A is equal to P of E1 given A. P of E1 50 divided by 100. Correct? 50 divided by 100. P of E1 divided by 100, 50 divided by 100 into 1 divided by 100, 1 divided by 100. So 50 divided by 100 into 1 divided by 100, 1 divided by 100 plus 30 divided by 100, 30 divided by 100 into 5 divided by 100 plus 20 divided by 100, 20 divided by 100 into 7 divided by 100, 7 divided by 100. So simplify it. Simplified, so 0 0 get cancelled, or else better don't cancel it. The LCM is what? 100 into 100, 50 into 150, 50 plus 150 plus 140 whole divided by 100 into 100, 50 divided by 200, 340, 340, yes, 150, 50, 200, 200, 300 and 340. So answer is 5 divided by what? 34. 5 divided by 34. So this is very interesting problem and very important problem. Next problem. So last problem in that exercise. A cord, I write the problem, it's very simple sentence. A cord from a pack of 52 cords is lost. Very interesting question, very different question. From the remaining cards, from the remaining cards of the pack of the pack, two cards are drawn. Two cards are drawn and are found to be both diamonds, find the probability of the lost card. A lost card being a diamond. Lost card being a diamond. Something different problem regarding all problem what we solved in the Bayes theorem. This is different problem. A card from a pack of 52 cards. A card from a pack of 52 cards is lost. From the remaining cards of the pack, two cards are drawn and are found to be both diamonds. Find the probability that the lost card being a diamond. So we write the answer. Okay, so we write one by one event solution. So even the last event that the lost card is a diamond. Let E1 be the event that the lost card is a diamond. The lost card is diamond. E2 be the event that the card is, or the lost card is not a diamond. The lost card is not a diamond. How many diamond cards are there? 13 cards. So probability of E1. So probability of E1 is what? 13 cards. 13 divided by 51. Correct? Then probability of E2. Probability of E2 is how much? Probability of E2, 13 means 39 divided by 51. 39 divided by 51. 13 by 51 and 39 divided by 51. Okay. Next, so we define an event A. Let A be the event that two cards drawn from the remaining pack two cards drawn from the remaining pack are diamond. So P of E1, a lost card is, because why I write 51? One of the card is lost. So then probability of A given E1. Probability of A given E1. So one card is lost, 12C2 divided by 51C2. Probability of A given E2 is 13C2 divided by what? 51C2. So to find what probability of E1 given A. To find probability of what? E1 given A. To find probability of E1 given A. So okay, according to the Bayes theorem, P of E1 given A is equal to P of E1 into P of A given E1 divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2. P of A given E2. So P of E1 into P of, why I write 2? Because we are selecting two cards, here from the last card, here not from the last card. Okay, P of A given E2. Substitute all the values. Substitute all the values. So that implies P of E1 given A. P of E1 13 divided by 51 into P of A given E1 12C2 divided by 51C2 whole divided by 13 divided by 51 into 12C2 divided by 51C2, 12C2 divided by 51C2 plus 39 divided by, yes now 39 divided by 51 into 13C2 divided by 51C2. So it is in the form of what? NC2. So you know NC2, since NC2, N into N minus 1 divided by what? 2 factorial. NC2, N into N minus 1 divided by 2 factorial. So that is equal to 13 divided by 51 into. So 12 into 11 divided by 2 whole divided by 51 into 50 divided by 2. 13 divided by 51 into 12 into 11 divided by 2 whole divided by 51 into 50 divided by 2 plus 39 divided by 51 into 13 into 12 divided by 2 whole divided by 51 into 50 divided by 2. Both sides 2, 2, 2, 2, 2, what? Get cancel. 2, 2 get cancelled. So remaining I left to you, simplified it and write down the answer. Simplified it and write down the answer. That is I left to you only. Okay, you simplified it and find out the remaining answer. Or else, okay, you find out the final answer. Very simple question answer. Next question. Next one, 13th question. Probability that speaks truth is 4 by 5. A coin is tossed. It reports that a head appears. The probability that actually there was head is option A 4 by 5, option B 1 by 2, option C 1 by 5, option D 2 by 5. So very simple question. So what I left previous problem, you solved it. If you are not get the answer, in the next class I solve the answer. Why I given this one? Very simple lengthy calculation. You simplified it, take LCM and simplified it. If you are not get the answer, in the next class I will give the answer. Just I given to you work. So probability that a speaks truth is 4 by 5. A coin is tossed. A reports that a head appears. The probability that actually there was head. There was a head. 4 options are given. So we solve same by using Bayes theorem concept. Bayes theorem concept. See, observe here how to solve this one. See. So we write one by one event. Probability that E1. A coin comes with head. Coin comes with head. This is E1. So E2. Coin comes with tail. These two are the events. So probability of E1 is equal to probability of E2 is equal to 1 by 2. Okay. So reports that head appears. Let A reports that head appears. Head appears. So probability of A given E1 he has given. So how much it is? 4 by 5. Probability of A given E2 1 minus 4 by 5. So that should be 1 by 5. So therefore actually there was a head. There was a head means E1. To find probability of E1 given A. According to the Bayes theorem, P of E1 into P of A given E1 divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2. Substitute all the values. So 1 by 2 into 4 by 5 whole divided by 1 by 2 into 4 by 5 plus 1 by 2 into 1 by 5. Very simple calculation. 1 by 2 into 1 by 5. Right. So that is equal to numerator LCM 10, 4, here also 10, 4 plus 1, 10 get cancelled, answer is 4 by 5. Option is there, 4 by 5, option A. Very simple question. 4 by 5, option is A is the correct answer. 13th question over. 14th question. 14th question. If A and B are two events, A and B are two events such that A subset of B and P of B not equal to 0, then which of the following is correct? Which of the following is correct? Option A, P of A given B, P of B divided by P of A. Option B, P of A given B is less than P of A. Option C, P of A given B is always greater than or equal to P of A. None of these. None of these. This is for one more question. Since A is a subset of B, A is a subset of B, A intersection B is equal to A. Correct? A is a subset of B, A intersection B is equal to A. So, P of A given B is equal to P of A intersection B divided by P of B. P of A intersection B divided by P of B. So, that is nothing but what? P of A divided by P of B. Since P of B is less than or equal to 1, that implies P of A given B is always greater than or equal to what? P of A. P of A given B is always greater than or equal to what? P of A. So, option C is correct. For this option C is correct. So, this completes the exercise what 13.3 finish up. So, we go for some worked example problems also, because these worked example problems, they are very important for annual examination. Okay. So, one by one we see the worked example problems. So, better first simple worked example problem, that is 16th one. Example 16. Bag 1 contains 3 red and 4 black balls. Bag 1 contains 3 red and 4 black balls, while another bag 2 contains 5 red and 6 black balls. 6 black balls. Full stop. One of is drawn at random from one of the bags, and it is found to be red. Find the probability that it was drawn from bag 2. It was drawn from bag 2. See this problem. So, this type of problem already we discussed in the exercise problem. First exercise problem, first problem we discussed same concept. So first we observe the concept. So this is sample space. In that sample space, two bags are there. So those two bags we call it as E1 and E2. No doubt these two are mutually exclusive and exhaustive events because their union is nothing but sample space and their intersection is nothing but empty space. So the first bag contains 3 red, 4 black balls. The second bag contains 5 red and 6 black balls. What is the event? One of the ball is drawn from the bag, it was found to be red. A be the event that drawn ball is red. Drawn ball is red. So then probability of A given E1. In the bag 1, how many red balls are there? 3 red. 3 divided by 7. Probability of A given E2. In bag 2, 5 red balls are there. 5 divided by 11. Then what is the question? Find the probability that it was drawn from bag 2. That means to find probability of E2 given A. To find what? Probability of E2 given A. This is what the concept of the given problem. Okay, we solve step by step. So let E1 be the event of choosing the bag first, means the bag 1. E2 be the event of choosing the bag 2. So probability of E1 is equal to probability of E2 is equal to what? 1 by 2. First one is over. Correct? Probability of E1, probability of E2 is 1 by 2. Then we write the event. Let A be the event. Let A be the event of drawing what? A red ball. Of drawing what? A red ball. A be the event of drawing a red ball. Probability of A given E1. Total ball, red ball in bag 1, 3. 3 divided by 7. Probability of A given E2. In bag 2, how many red balls are there? 5 and total ball is 11. 5 divided by 11. To find probability of E2 given A. To find probability of what? E2 given A. According to Bayes theorem, probability of E2 given A, probability of E2 into probability of A given E2 whole divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Probability of A given E2. Substitute all the values. So after substituting, so that is equal to 1 by 2, P of E2 is 1 by 2, 1 by 2 into P of A given E2, 5 divided by 11 whole divided by 1 by 2 into 3 by 7 plus 1 by 2 into 5 divided by 11, that is equal. So multiply 5 divided by 22, 3 divided by 14 plus 5 divided by 22. Thirty-five divided by what? 68 is the answer. 35 divided by 68 is the answer. This is the first worked example problem. Next worked example problem, 17th one. Seventeenth worked example problem. Given 3 identical boxes, first, second and third, each containing 2 coins, in box 1. Both the coins are gold coins. In box 1, both the coins are gold coins. In box 2, both are silver coins. Both are silver coins. And in box 3, there is one gold coin and one silver coin. A person chooses a box at random, and takes out a coin. If the coin is of gold, what is the probability? What is the probability that the other coin in the box is also of gold? Very important problem. So given 3 identical boxes, 1, 2 and 3, each containing 2 coins. So in each box 2 coins are there. In box 1, both the coins are gold coins. In box 2, both the coins are silver coins. And in box 3, one is gold coin, another one is silver coin. So Better we first observe the concept. In the sample space S, 3 boxes are there. In box 1, these 3 boxes we treated as mutually exclusive and exhaustive events. In the box 1, why we treat as mutually exclusive and exhaustive events? Because if a union, it gives sample space. If a intersection, so it gives empty set. In box 1, 2 gold coins. 2 coins are gold. In box 2, 2 are silver coins. Silver coins. In box 3, 1 is gold coin, 1 is silver coin. 1 is silver coin. So, if the coin is gold, what is the A event? A event is taking a gold coin. That should be the A event. Taking a gold coin. That should be the A event. What is the probability that the other coin in the box is also a gold? With respect to what? E1. Probability of E1 given A. What do we have to find out here? Probability of E1 given A. Okay. We solve the problem. After knowing the concept very well, we solve the problem. See, observe here, let E1, E2, E3 be the events that boxes 1, 2 and 3. P of E1, P of E2, P of E3, that is 1 by 3. A be the event, A be the event, the coin drawn is gold. The coin drawn is gold. The coin drawn is gold. So, probability of A given E1. Probability of A given E1, 2 coins are gold, it is 1. Probability of A given E2, 0 by 2, so answer is 0. Probability of A given E3, 1 by 2, because 1 silver coin and 1 is gold coin. Okay. So, to find what? Probability of E1 given A. Probability of what? E1 given A. So, probability of E1 given A is equal to P of E1 into P of A given E1 whole divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of what? A given E3. So, this is what? According to the what? Bayes theorem. According to Bayes theorem. Substitute all the values. So, P of E1, 1 by 3 into A given E1, it is 1. 1 by 3 into 1 plus P of E2, 1 by 3 into P of A given E2, 0, lucky number, plus P of E3, 1 by 3 into 1 by 2. Okay. Simplified it, very simple simplification. 1 by 3, 1 by 3 plus 1 by 6. So, 1 by 3, 6 should be the LCM, 2 plus 3, 3. So, answer is 2 by 3. Answer is what? 2 divided by 3. See, observe the problem. This is very important problem for annual examination, to the point of annual examination, this problem is very, very, very important. Perfect this problem. This is very important. Next, one more worked example problem. Example 19. In a factory which manufactures bolts, machine A, B and C manufacture respectively 25%, 35% and 40% of the bolts. Of their outputs, 5, 4 and 2% are respectively defective bolts, are respectively what? Defective bolts. A bolt is drawn at random. A bolt is drawn at random from the product and is found to be defective. What is the probability that it is manufactured by the machine A, by the machine B? Manufactured by the machine B. So this is what the problem. So 3 machines are there, machine A, machine B and machine C. 25%, 35%, 40%. Their output, defective output is 5%, 4% and 2%. So A bolt drawn from the product and it's found to be defective. What is the probability that the manufactured by machine B? Machine A we treated as E1, machine B we treated as E2 and machine C we treated as E3. So A event is defective item, defective bolts. So we solve. This is also very important problem. See this problem. So A1 probability, A1 the bolt is manufactured by machine A. Let E1, the bolt is manufactured by machine A. E2, saying the bolt is manufactured by machine B. E3, saying the bolt is manufactured by machine C. Probability of E1, probability of E1 25%, 25 divided by 100. Probability of E2, probability of E2 35%, 35 divided by 100. Probability of E3 40%, 40 divided by what? 100, 40 divided by 100. So what about the event? Let A be the event. A be the event that the bolt is defective. Bolt is what? Defective. A be the event that bolt is defective. Probability of A given E1. Probability of A given E1 is how many percent is given? 5%. 5 divided by 100. Probability of A given E2 4%. 4 divided by 100. Probability of A given E3 2%. 2 divided by 100. So to find probability of what? E2 given A with respect to the machine B, correct? With respect to the machine B, probability of E2 given A. Probability of E2 given A. So according to the Bayes theorem, P of E2 given A is equal to P of E2 into P of A given E2 whole divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. P of A given E3. Substitute all the values. Substitute all the values. That is equal to. We substitute all the values. That is equal to P of E2 35 100. P of A given E2 4 divided by 100. P of E given 25 divided by 100 into 5 divided by 100 plus 35 divided by 100 into 4 divided by 100 plus 40 divided by 100 into 2 divided by 100. 2 divided by 100. Divided by 100. So the LCM is 100 into 100. That should be the LCM. Hundred into 100. Get cancel. 140. 140 divided by 345. 140, 140, So 35 into 5. 125, 140, 140 divided by 35. Further you simplified, the choice is yours. So I think I solved 3 worked example problems. Just I left out 2 worked example problems that I given to you. Okay. So this finish up the concept of what? Bayes theorem. This I finish up the concept of Bayes theorem. One problem I left to you, that is the 12th problem. Today you solved. If you don't get the answer, tomorrow that answer I will give you. Okay. So one more concept. Just simply we see the one more concept. Simple concept. Random variables and probability distribution. Random variables and probability distributions. This is the next concept in the probability chapter. Random variables and what? Probability distribution. We will see random variable means what and probability distribution means what. For that, what we do, we take one example. Tossing a coin 2 times. Tossing a coin 2 times. What are the sample space? The sample space are head and head, head and tail, tail and head, tail. Head and head, head and tail, tail and head, tail and tail. Number of heads in each sample point. The first sample point that we denoted by capital X is what? 2. The next is 1. Next is 1. Next, number of heads is 0. Number of heads. Similarly, if you want number of tails in each sample point, X of head and head, number of tail is 0. There is no tails. X of HT, it is 1. X of TH, it is 1. X of TT is 2. What we got, these values, a unique value, are called random variables. Are called random variables. Random variables. The definition is a random variable is a real valued function whose domain is the sample space of a random experiment. Whose domain is the sample space of a experiment. Domain is the sample space of a experiment. It is a, see, observe here, random variable is a real valued function. Real valued function. So random variables are denoted by XX. A real valued function whose domain is the sample space of an experiment. These are called the domains. Observe here, random variable is a real valued function. See, observe here, it gives the real number. It gives the real number. Random variable is a real valued function whose domain is the sample space of an experiment. This is about the random variables. See here, number of heads I take, number of tails. Then we will see what about the probability distribution. And one more very important topic, random variables are denoted by capital X, capital Y, capital letters. Okay. So once again I explain the definition. Random variable is a real valued functions whose domain is the sample space of an experiment. Okay, so we take any one example, random variables for number of heads. Number of heads. Number of heads, x of HH is 2, x of HT is 1, x of TH is 1, x of TT is 0. These values we call it as random variables. I think you clear about the random variables. What about the probability distribution? For each random variable, if you find the probability value, so suppose probability of, for this one, probability of x is equal to 2. How many favorable outcome is there? Only one. 1 divided by 4. Total number of outcome is 4. Probability of x is equal to 1. How many outcomes are there? HT, TH. 2 divided by 4. Probability of x is equal to 0. How many outcomes are there? Only one outcomes. 1 divided by 4. This we call it as what? The probability distribution. So the probability values with respect to the random variables, probability values, observe here, probability values with respect to the random variable is called what? Probability distribution. One more very important here. So Pi, probability value, is always greater than or equal to 0. It is always positive. And sum of Pi is 1. Always 1. Summation of Pi. So observe here, one more very important. If you club greater than or equal to 0, less than or equal to 1. Means all Pi, all probability values lies between 0 to 1. And one more very important, if you add all the probability values, it is always equal to 1. See, observe here, 1 by 4 plus 2 by 4 plus 1 by 4. Answer is 4 by 4. Summation, if summation is equal to 1, then only we call it as, these probability values we call it as probability distribution. Very important topic. So the probability values for each random variable is called probability distribution, and it satisfies one condition. Pi values lies between 0 to 1, not negative, not more than 1. And one more very important condition, summation of Pi if is equal to 1, then only we say that probability distribution. If summation of Pi is not equal to 1, we can't say it is a probability distribution. That is very important. Okay, so probability distribution means, so probability values for each random variables. That's the first one. And Pi value greater than or equal to 0, less than or equal to 1. Very important condition. Sum of Pi is equal to 1, then only we say that it is a probability distribution. If sum of Pi is not equal to 1, we can't say it is a probability distribution. This is what the concept of random variable and probability distribution. Random variable is a real valued function, whose domain is or nothing but sample point. What about probability distribution? Probability distribution, all Pi greater than or equal to 0, less than or equal to 1. And summation of Pi with respect to the random variables. Summation of Pi with respect to random variable is equal to 1. Then only we say that it is a probability distribution. This is the next concept of what? Random variable and probability distribution. So better we solve some problems regarding random variable and probability distribution. Exercise 13.4. 13.4. First problem. State which of the following are not the probability distributions of a random variable. Give reason. If not, give reason. If it is, yes, give reason. First problem. X, P of X has given 0, 1, 2. 0.4, 0.4, 0.2. 0.4, 0.4, 0.2. Observe here, all pi greater than or equal to 0. Positive. Correct? First condition satisfies. Summation of pi. 0.4 plus 0.4 plus 0.2 is equal to 1. Hence, so which of the following is a probability distribution of random? Given, hence, given distribution is a probability distribution of a random variable. Given distribution is a probability distribution of a random, because all pi are positive and summation of pi is equal to 1. If these two conditions satisfies, the given distribution is a what? Probability distribution of a random variable. First problem is over. Second problem. Second table. Okay. Is it a probability distribution? See, observe here. P1, P2, P3, P of X is equal to 3. He has given minus 0.1, less than 0. If it is a probability distribution, all pi must be positive, greater than or equal to 0, less than or equal to 1. So this is less than 0, negative. Hence, it is not a probability distribution of a random variable. It is not a probability distribution of a random variable. One more problem. He has given y. Okay, what I say? Random variables are denoted by capital alphabet letters y, minus 1, 0, 1, p of y 0.6, 0.1, 0.2. Okay, no doubt. All pi greater than or equal to 0, positive. First condition satisfies. Summation of pi 0.6 plus 0.1 plus 0.2 is equal to 0.9, not equal to 1. This is the reason. If it is a probability distribution, sum of pi is always equal to 1, hence because it is less than 1, hence it is not a probability distribution of a random variable. Probability distribution of a random variable. One more problem is there. Fourth one. .05. No doubt, all pi's greater than or equal to 0, positive. First condition satisfies. Second condition, summation of pi plus 0.05, 5. So 1.05 greater than 1, hence it is not a probability distribution of a because summation is always equal to what? 1. It is not a probability distribution of a random variable. This is about the concept of what? Random variable and probability distribution. Once again I explain, random variable means it is a real valid function whose domain are nothing but simple point of the random experiment. Probability distribution, probabilities values with respect to the random variable, it is always greater than or equal to 0, less than or equal to 1, means positive, and summation is always equal to 1. If these two conditions satisfies, the given probability values are called probability distributions. Up to this we stop. We continue the remaining problems in the next class. Thank you.